Welcome to my YouTube channel. In this video, we are going to show you how to calculate the eigenvalue of a given matrix. So in this case, we are given a 3 by 3 matrix and we are to find the eigenvalue of that particular system. So what we do is to bring in our eigenvalue problem, which is given by this expression. Now our M here is the matrix, our X here is the eigenvector, which is equal to our eigenvalue multiplied by the eigenvector. So to solve this, we take this one to this other side and it gives us this. From here, we notice that this is a vector quantity and this is a scalar quantity. So to subtract a scalar from vector quantity is not too proper. So what we do is to multiply our vector quantity with our scalar quantity with another vector quantity, which makes it 1. So we multiply it with a unit vector quantity, which is I. So now that these two, when they multiply each other, becomes a vector quantity, we can now conveniently subtract it from M, which is a vector quantity. And we'll factorize our X out, which is the eigenvector, from that equation. And we are left with M minus lambda I. Now, because our M is a 3 by 3 matrix, our I is also going to be a 3 by 3 unit matrix or identity matrix. Now, what we'll do is substitute this expression into this, then minus the value of lambda multiplied by the unit matrix equal to 0. So that's what we'll see in the next slide. So what we now have is the determinant of this. But remember, from our equation, as we have this expression is multiplying this expression, which is equal to 0. Now, when two parameters are multiplying each other equal to 0, one of them has to be equal to 0. Our x cannot be equal to 0 because if x is equal to 0, x here will be equal to 0, everything here will be equal to 0, and this equation will be meaningless. So rather, this expression will rather become 0. And if this one is equal to 0, the next slide will show us how to present it. Now, the determinant of this expression will now be equal to 0. So by the time you substitute this expression, this is our M minus this is our lambda, this is our unit matrix equal to 0. So you substitute this one into this, you have lambda, 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 everything here. Then this expression, which is this, will be subtracted from this. So we have 1 minus lambda, half minus 0, 0 minus. So at the end, we get this expression. So determinant of this is equal to this. And you know the expression for determinants is to take this first one, multiply by this minus this times this minus this times this. So we are going to find the determinant of this matrix. Now, this is the expression. We take the first one, multiply by the two other expression and equal to this. Now, if you look at this expression, it's a little bit lengthy, and at the end of the day, there is likelihood of you making mistakes. At the end of the day, the final expression is going to be in this form, which is equal to minus 3 lambda. So if you minus lambda cubed plus 7 over 2 lambda squared. If you multiply minus 1 throughout, you get this final expression. So what we want to present to you is another way of determining this expression without going through that step that I showed you in the previous slide. Okay. We'll generate an expression in this form, lambda cubed minus a box lambda squared plus a box lambda minus a lambda. Take note of the sign, minus plus minus, lambda cubed, lambda squared, lambda equal to 0. So instead of going through that other process of expounding and collecting like terms and doing your calculation, all we just need to do is to find out what to do to get this value. So to get this value, what we'll do is to add these terms along the diagonal, to add them. And to add them, we have 1 plus 3 over 2 plus 1. And that will give us 2 plus 3 over 2, which is equal to 7 over 2. And if you notice, 3 over 2 plus 2 will give us 7 over 2. That will just give us this term here, 7 over 2. To get this term, what we just need to do is to multiply this by this by this, and this by this. So we'll do it this way. 1 and this will give me 1 3/2. We'll add it. 1 and this will give me 1 into 1. We add this and this will give me 3/2 into 1. They will now say minus. We multiply these two terms to be half into bracket half plus this and this will give me 0 plus this and this will give me half into half. At the end of the day, we notice that this and this will give me 3. 3 plus 1 will give me 4. So I have 4 minus this and this will give me 1/4 plus 1/4 will give me 1/2. And 4 minus 1/2 will give me 7/2. 7/2 will now be written here. You can see you don't have to go through that long process of expounding. Here will give me 7/2. To know what is here, we just take the determinant of this expression. And to take the determinant of this expression, very easy. This is what we do. We take 1 into bracket 3/2 times this minus this times this, which is this, minus half times 1 minus 0 times this, which will give me this. So by the time we simplify this, it will give me 3/2 minus 1/4. This and this will give me this expression. At the end of the day, we'll get 1. We'll now substitute into the last term, which makes it looks like this, which gives us 1. So if you compare this equation to the previous time that we solved, you discover that they are exactly the same thing. And at the end of the day, all you just need to do is to avoid solving in that process. So you can see this expression and this expression that we solved previously, they are exactly the same. Lambda cube minus 7/2, and 1. So I hope this helps. Thank you. Please share and subscribe.